Good morning. I just wanted to continue on with what we were talking about in the last video, which is where we kind of ended on the proof of the alternate interior angle theorem. So in this proof, the one that we see on screen, I'm going to look to prove the alternate exterior theorem. So just like before, we have some corresponding angles that we can interconnect and make relationships towards. And inevitably, I want to be able to prove that angle 1 and angle 8 are congruent. So let me highlight those to make those kind of stand out. So I want angle 1, so this guy right here, and angle 8, this guy over here, to be congruent. So at the end of the day, as long as I can prove that those two angles are congruent, I've successfully done my job. So given information, same given information as last time, A and B are parallel. We can see that indicated by the red arrows. And we know that T is the transversal, the line that bridges the two parallel lines and enables us to create these angles here, 1 to 8. So now I want to prove that 1 and 8 are congruent. And so just like last time, I have a few theorems and postulates at my disposal. I have access to the CAP, or corresponding angle postulate. I have access to the VAT, or vertical angle theorem. And now I have access to AIA, or the alternate interior angle theorem. So I have access to 3 theorems and postulates that enable me to say some angle congruences. So right off the bat, using VAT, I can see that 1 and 6 are congruent, so that might be helpful. And I can also see that 3 and 8 are congruent, so these are also helpful in that respect. So just like before, I have access to the corresponding angle postulate, and that enables me to say that any corresponding angles that I can see are going to be congruent. So I can see that 1 and 3 are going to be congruent. I can see that 2 and 4 are going to be congruent. 5 and 7 are congruent. And 6 and 8 are congruent. So this corresponding angle postulate allows me to say that just very easily. So kind of what strikes me here is we can use the corresponding angle postulate to prove 1 and 3 congruent, like we did before, and then vertical angle theorem to prove 3 and 8 congruent. So we have access to that as well. So in a very similar vein to the alternate interior angle theorem, we can do those kinds of things. So let's start by writing some stuff down. So our first statement, just like always, is going to be our given statement. So in this given statement, our reason is always that the information is given to us, and the statement is always going to be kind of a reiterance of our given information. A and B are parallel, and T is the transversal. So we have that information just kind of reinstated for us. So we have it rewritten and easily visible when we continue working. So the next statement and next given piece is just kind of what we're doing, the building blocks that are going to get us to our inevitable answer, that 1 and 8 are congruent. So I can either start with vertical angle theorem, so I can prove that 1 and 6 are congruent, or I can prove that 3 and 8 are congruent. I can do that first, or I can do the corresponding angles. I'm going to do corresponding angles because I like to treat it like a roadmap. So in my case, if I can go from 1 to 3 and then from 3 to 8, I've successfully connected 1 and 8, which is what I want. So corresponding angles allows me to say that 1 and 3 are congruent. So I'm going to write that as my statement. Angle 1 is congruent to angle 3. And I know this because of CAP, again, corresponding angle postulate. So now I have that proof. I know that 1 and 3 are congruent. Now I want 1 and 8, so I'm almost there. Now I just got to bridge 3 to 8, and I have that as well. So in this case, same as before, I can say that the angles 3 and 8 are congruent, and I can say that because of the vertical angle theorem, or VAT. So now at this point, I have now interconnected 1, 3, and 8, but I have to use a final property to connect them all. So in this case, I can use the transitive property, just like in the previous proof, to state that angle 1 is congruent to angle 8. And in doing so, I have effectively proven what I need to do. So transitive property of equality. Alrighty, so I've got that transitive property there, and in doing so, that final step has allowed me to state that angle 1 and angle 8 are in fact congruent. And with that final statement, I can now call this entire proof the alternate exterior angle theorem. Alternate exterior theorem, well, alternate exterior angle theorem, to be perfectly specific. And so now, just like the alternate interior theorem, I can say AIA or AEA, and I would be able to prove, without a shadow of a doubt, that those angles are in fact congruent. So with that, hopefully this helps.